Hello, our viewers. Today we'll try to discuss about vector. And when we are trying to discuss about vector, we'll try to revise some main points. And these points are, we'll try to define what vectors are, and we'll try to list some of the types of vectors. Then we'll try to use the vector notation forms. And we'll be able to resolve vectors into its components. And the other thing is we are able to calculate vector, we are able to operate vectors into, we are able to add vectors and subtract vectors graphically or mathematically. And we'll try to appreciate the parallelogram methods and the triangular methods of vector adding and subtracting. We are also able to see vector multiplication, the scalar product and vector products. So first, let's try to define what vectors are. Vectors are mathematical tools which are very helpful in physics. Especially when we are trying to discuss about different quantities, we are able to apply vectors. Physical quantities are anything which are measurable directly or indirectly. Therefore, it's possible to classify physical quantities into two. The first thing is, according to their derivation, it's possible to classify physical quantities as fundamental and derived. But the other thing, depending on the direction content, it's possible to classify physical quantities as vector and scalar. So our main concern is to discuss about vectors. Scalars are physical quantities which are designated only by magnitude. Magnitude only. Well, magnitude means it is something which consists of number and units. Whereas vectors represents or designated by both magnitude and direction. That means there is magnitude, which means number plus unit, and there will be a direction. So therefore, vectors are very important mathematical tools which are helpful for physics. Some of the common vectors are force, velocity, acceleration, momentum, and so on. We have a lot of vector quantities. Suppose here you have a force which is acting 100 Newton due east. 100 Newton force is acting on something due east. Therefore, 100 is a number, Newton is unit. Therefore, number plus unit is called magnitude. Whereas east is direction, therefore, vector quantities always consists both magnitude and direction. And how do we represent vectors? Well, vectors are represented by using arrows. We have arrows. We have initial and final points. Suppose here we have point O and point A. Therefore, it's possible to represent this vector as OA and arrow over it. It's possible to represent like this. Or it's also possible to use a single letter. For example, here you do have V. Therefore, you can use V and arrow over it. Or it's possible to use a bold-face letter, V. You should have to make it bold. Therefore, this is how we represent vectors. The initial and the final, the length of the arrow represents the magnitude, and the head of the arrow represents the direction. Therefore, vectors are represented by using both magnitude and direction. Now let's try to classify the types of vectors. There are different types of vectors. Mainly in mathematics we have several vectors, but in physics we mainly focus on some of these vectors, and these are equal vectors, null vector, collinear vectors, coplanar vectors, and unit vectors. These are the main vectors that we need to focus. What do you mean by equal vectors? Well, two vectors are said to be equal if and only if they have the same magnitude and the same direction. So two vectors are said to be equal vectors if and only if they have equal in magnitude and the same direction. This is how we represent two vectors are said to be equal. And we have also a null vector or a zero vector. Null vectors are vectors also known as to be zero vectors. The difference of two vectors might give us 0, but 0 is said to be zero vector. It's called zero vector or null vector, and its direction is arbitrary. And the other concept is collinear vector. As the name implies, collinear means the same line. Vectors which are found on the same line are said to be collinear vectors. They might act along the same direction or opposite direction. As far as they are found on the same lines of action, it's called collinear vectors. Here we have two opposite vectors. They are acting oppositely, but they are found on the same lines of action, so they are said to be collinear. Here as well, the two vectors are acting on the same direction, but they are found on the same lines of action. They are called to be collinear vectors. And the other point is coplanar vectors. Coplanar vectors are vectors which are found on the same plane, Here we have x, y, z Cartesian coordinate system. On this Cartesian coordinate system, you might have a plane, x, y plane. Here we have x, y plane, and at the bottom we have x, z plane, and on this side we have y, z plane. Okay. On each plane we have different vectors. Here we have vector a, p, q. All those vectors are found on xy plane. So those three vectors are said to be coplanar vectors. Whereas these two vectors, b and r, are found on xz plane. Therefore, these are coplanar. But here, vector b cannot be said as with that of a are not collinear vectors. Since they are found on different vectors, they are not said to be collinear vectors. Therefore, collinear vectors are vectors which are found on the same plane. The other important vector is position vector, and it's the most common vector. Position vectors are vectors which are used to represent the position of something with respect to a well-known object or a well-known point. Therefore, it's possible to represent those position of vectors using bearing, polar, and component forms, different techniques of representing position vectors. The first method is using bearing. Bearing is a technique of representing the position of something with respect to a north pole, or it's possible to say a positive y-axis. So from positive y-axis clockwise. Suppose here you have a point B, and point B is 4 kilometers away from point O. So it's found at 4 kilometers away from point O. To which direction? To the east, to the north? In which direction? Here it says it is 60 degrees from north. So bearing means always you are referring from north pole. Therefore, in this case, point B is 4 kilometers away from point O. Bearing 60 degrees means from north pole, clockwise 60 degrees. In this context, it's possible to say north to east, 60 degrees. So such a method of representing the position of something is known to be bearing. The other technique is polar form. Polar form is used to represent the position of an object from positive x-axis, or we call it to be east, and it should be anti-clockwise. Therefore, here the same point B can be represented using polar form as it is 60 degrees from north, but we are counting to use polar form from east direction of positive x-axis. Therefore, this should be from complementary angle, it's 30 degrees. The same distance, 4 kilometers. Therefore, to represent using polar form, you have to represent the distance as well as the angle. The distance is 4 kilometers, okay, 4 kilometers, and the angle should be measured from the positive x-axis, not from north axis. It is for bearing form, you have to use from north axis, but polar form used from x-axis, positive x-axis, or from east. Therefore, it should have to put 30 degrees. And the third method is the most common method, and it is known to be component form. Therefore, a given vector can be decomposed into its coordinates, into x-axis, y-axis, or z-axis. Therefore, component method is splitting of a given vector into its components. Suppose here you have a vector, the previous vector that we have said, from O to B. Therefore, it's possible to decompose this vector into x-axis and into y-axis. From your mathematics lesson in trigonometry, you know that sine theta means opposite over hypotenuse. And the opposite of this is the component of this vector along the y-axis. And that is the component of vector B along the y over the hypotenuse. The hypotenuse is vector B. Therefore, the component of vector B along y means the magnitude of vector B sine theta. This is how we represent the component or this is how we split this vector. It's also possible to decompose this vector along the x-axis. From your mathematics lesson as well, you know that cosine theta represents adjacent over hypotenuse. And the adjacent of this is the component of this vector along the x-axis. Let's call it to be bx. Over the magnitude is b. Therefore, when you crisscross, you can find that the magnitude, the split or the component of this vector along the x-axis is the magnitude of b cosine of theta. It's also possible to decompose this vector onto the z-axis. Usually we focus only on the two dimension, on the x-axis and on the y-axis. Okay, it's also possible to decompose it along x, along y, and along z, which is the axis which is acting or directing towards you or towards me. X-axis, y-axis, and z-axis. Therefore, it's possible to see on 3 dimension. It's also possible, we usually focus on the 2-dimensional vectors. Therefore, it's possible to decompose that. Here you have one good example. The previous example, we have 4 kilometer from O to B is 4 kilometer, and the angle is 30 degree. Therefore, what is the component of this vector onto the x-axis and onto the y-axis? Therefore, to determine the component of this vector along the x-axis is b cosine of theta. B is 4 kilometer, cosine of theta is 30 degree, cos 30 gives us 0.866. Therefore, when you multiply this, you can find it to be 3.5 kilometer. And it's also possible to find the y component, this component, and by is b sine theta, and b is 4 kilometer, and sine 30 is 0.5, or it is 1 over 2. Therefore, 0.5 times 4 gives us 2 kilometer. Therefore, here you have 2 kilometer, here you have 3.5 kilometer. The summation of these two gives us 4 kilometer, which means 3.5 kilometer along the x-axis plus 2 kilometer along the y-axis. You are not going to add linearly. It's not a scalar. If you add these two, this gives you 5.5. If it is a scalar, it's possible, but it's a vector. For vector, you should have to indicate its direction. 3.5 to which direction? To the x direction. And 2 to the y direction. Should give us 4. Okay, should give us 4, and that can be found using squared, and under radical. You can find it to be approximately 4. This is how we determine for vectors. Now let's proceed. And the other most important vector is unit vector. And unit vector, as the name implies, the magnitude of the vector is unity, which means 1. The magnitude should be, or the modulus, we call it to be modulus, norm, or magnitude should be 1. And to represent the unit vectors on each axis, we have 3 coordinates, x-axis, y-axis, and z-axis. The unit vector which is acting along the x-axis is said to be I. The unit vector which is acting along the y-axis is said to be j, and the unit vector which is acting along the z component is called k. All their magnitude is 1. The only thing they represent into the x, y, and z. Here, how do we represent the unit vector along suppose you have vector A, and it's possible to represent it using I, j, and k. Ax in the I, ay in the j, plus az in the k means the component of this vector along the x, along the y, and along the z direction can be represented using I hat, j hat, and k hat. This is what we call unit vector notation form. And how do we determine the magnitude of this? Well, the magnitude or the norm or the modulus of this vector is determined by squaring every component. Ax squared plus ay squared plus az squared gives you the magnitude of this vector. And it's possible if you try to determine the magnitude of this vector, and if you find it 1, so that this vector is said to be unit vector. Unless if it is different from 1, therefore it's not a unit vector. And it's possible to determine the unit vector of any given vector. Suppose here, let's see, you have a given vector here. First, we need to determine the magnitude of this vector. How do we determine the magnitude? You should have to square every component. Here, the I component, or the component along x, is 2, the component along y is 1, and the component along the z component is -1. Okay? If you square all the quantities, 2 squared, 1 squared, and minus 1 squared gives you 6, root 6. And root 6 is not equals to 1. Therefore, this vector is not a unit vector. Then how do we determine the unit vector of this vector? It's possible to determine the unit vector of this vector. How? To determine the unit vector of a given vector A, for example, X in the I, AY in the J, you have to put the vector itself over its magnitude. Therefore, if you have vector A, to determine its unit vector, you have to put the vector itself over the magnitude of the vector. Therefore, in this case, you have a vector called B. To determine its unit vector, B hat, whenever you put hat means unit vector, okay, is equals to the vector itself B over the magnitude B. This is how we determine the unit vector of this vector. Therefore, previously we have found or we have checked that this vector is not a unit vector. Therefore, to find the unit vector of this, you have to put the vector itself, that means 2 in the I plus j minus k, over the magnitude. The magnitude is, we have already determined it to be root 6. So therefore, when you put it over root 6, you can find that 1 over root 6 times the vector to the I plus j minus k. And when you multiply this, you can find this vector. And this vector is for sure a unit vector. How do we know? You have to determine the magnitude of this. When you try to determine the magnitude of this, it will give you 1. If so, this vector is a unit vector. Let's check that. 2 over root 6 the whole squared, 1 over root 6 the whole squared, minus 1 over root 6 the whole squared. When you squared it, this gives you 6 over 6 under radical, and that gives you 1. Therefore, it is a unit vector. This is how we check vectors, whether they are units or not. Let's proceed. Now let's try to see vector operation. Vector operation means how to add, subtract, multiply vectors. It's possible to add, subtract, or multiply vectors using geometrical means and analytical means. First, let's try to see the geometrical means of vector adding and subtracting. Therefore, it's possible to use the most common geometrical means of adding and subtracting vectors are triangular, parallelogram, and polygonal methods. Actually, triangular and parallelogram methods of adding and subtracting vectors is used for only 2 vectors. But polygonal methods is very helpful to determine, subtract, and add vectors more than 2. Suppose here you do have vector A and vector B. Vector A is acting on this direction and vector B is acting on this direction. So the summation of these 2 vectors, or the difference of these 2 vectors, can be given. First, using triangular method, you should have to connect head to tail connection. That means when you put this, you can connect the tail of the first. The head of the first should be connected to the tail of the second. The tail of the second means here you do have vector B. The tail of the second must be connected to the head of the first vector. Therefore, as you connect this, the resultant is from the tail of the first vector to the head of the second vector gives you the resultant vector. This is the resultant vector. This could be the summation of the 2 vectors. If you are asked the difference of these 2 vectors, it's possible you have vector B, then reverse the direction. When you reverse the direction, it becomes minus B, the negative of B. Okay, so the difference of A minus B can be determined by connecting the tail of the first to the head of the second. This is known to be the difference of the 2 vectors. Therefore, it's possible to add or subtract the 2 vectors using a triangular method. The other technique is using parallelogram method. And parallelogram method, you should have to connect the 2 vectors at the tail-to-tail connection. Here, you have tail of the first to the tail of the second. It's possible to connect. Then it's possible to make a parallelogram. Parallelly, you can drop this, and parallel, you can drop this, and this figure seems to be parallelogram. And the resultant is from the tail-to-tail connection to the head-to-head connection. The same thing appears as that of a triangular method. So this technique is known to be parallelogram method. And the other is polygonal method. Polygonal method is very helpful to add or subtract vectors more than 2. Okay. Suppose here you do have A, B, C, D, and the like. So to add those 2 vectors, you should have to connect all the vectors head to tail connection. For example, let's try to find the summation of A, B, and C plus D. All of these vectors might be added. Therefore, you should have to connect head to tail. You should have to shift B here, from the head of the first to the tail of the second. Then you should have to move and put C here, from the head of the second B, and tail of C is connected, and the like. Therefore, the resultant will be from the tail of the first to the head of the last. Okay, this is how we determine vector using geometrical means. And we have seen triangular methods, parallelogram methods, and polygonal methods. And the other concept is analytical method of vector adding and subtracting. The analytical method of vector addition and subtraction is using trigonometric concepts, sine law and cosine law. Here, it's possible to use component-wise. Okay, suppose you have vector represented by unit vector notation form, ax in the I, ay in the j, plus az in the k. The same thing, b and c can be given. If you want to determine the summation of those two vectors, a plus b, it's possible to use column-wise or row-wise, meaning it's possible to put all the components of a, ax, ay, and az, b, bx, by, and bz. Therefore, it's possible to add the correspondent vectors, ax with bx, ay with by, az with bz. If it is summation, you can add. If it is subtract, you can subtract. It's possible to add those two vectors using column techniques. Or it's also possible to use row-wise, meaning you can possibly put ax, comma, ay, comma, az, okay, and plus bx, comma, by, and bz, okay. Therefore, it's possible to add ax with bx, ay with by, az with bz. This technique is called row-wise, and this one is called column-wise. And the other law, the trigonometric or the mathematical method of vector adding and subtracting, is cosine law. And cosine law is very helpful to determine the resultant vector of two vectors. And this is, for example, here you have vector A and vector B. And those two vectors have an angle theta difference. Therefore, to determine the resultant vector, let's say that the resultant is C, using cosine law is a squared plus b squared plus twice of ab cosine of theta, where theta is the angle between the two vectors at the tail-to-tail connection. And it's possible to determine the magnitude of A and B. Previously, we have said that the magnitude of A and B can be determined by squaring. Magnitude of A is equals to, you should have to square all the components, x squared plus ay squared plus az squared and radical. This is known to be the magnitude of A. As well, it's possible to determine the magnitude of B and cosine of theta. This is called the cosine law. Cosine law is very helpful to determine the component of the magnitude of the two vectors, the summation or the difference of two vectors. And how do you determine the angle? The angle can be determined using sine law. Here you do have a sine law. Sine law is very helpful to determine the direction of the resultant vector. Suppose here the resultant vector is C, and how do you determine the angle of this resultant? It's possible to determine from x-axis or from vector A or from vector B. Let's say that this is alpha and this is beta. Okay, sine law states that the sine of this angle over the magnitude of the opposite side is equals to the sine of this angle over the magnitude of the opposite side is equals to, again, the sine of this angle over the magnitude of the opposite side. Let's see here. Sine phi over the opposite side is B. The magnitude of B is equals to sine alpha over the magnitude opposite to it is C is equals to sine beta over the magnitude of A. This is known to be sine law, and sine law is very helpful to determine the direction of the resultant vector. So students, this is all what I've got for today. Next time we'll try to see the vector multiplication. So see you then.